So the first thing that we are going to start today is constructor function. First, let us understand what is constructor function. Yesterday, we have created an object like this. Okay, this is an object, a student object here. And we performed all operations on this object. Fine. Now I have a special requirement. I want to create some 20 student objects. For example, if I take your session, 500 students are there. Now I want to write a program to save the details of your 500 students. Then what should I do? This is just one object which can represent one student. If I want to create another student, for example, let it be student 1. Now, if I want to create one more, then definitely I have to write this and let it be student 2, and I can change the values here. So the name can be some different, some ABC. And I have to create the third student here, and I can change the name, some meaningful name here like XYZ. And if I want to create one more student, so like that, this is the process I have to follow. So here I just created 4 objects, and each object has only 3 properties, and it is not even a complex object. It is very simple object. So if I repeatedly write the same simple object for 4 times, almost it has occupied 24 lines in this file. Imagine if it is a complex object which contains some 20 properties, and if I repeat that for 4 times, 20 into 4, 80 lines of code will be here. And if I want to create 100 objects like this, you can imagine the size of this file totally, how difficult it is to maintain, how difficult it is to understand, how difficult it is to update whenever it is required to make some change. And one more problem is, each object contains the same properties, only the values will be changed. Student 1 have different name, age, city. Student 2 have different details. So only the values will be changed, but the properties are same. So name, age, city, these are the 3 properties repeated for 4 times here. If I write some 100 objects in this way, so these 3 properties will be repeated for 100 times. That is not correct. We have to use the concept of reusability. Dry principle I already introduced to you. That is, do not repeat yourself. But here we are repeating them. If you take the object, so only values are different, but the keys are same. And we need to write the same keys again and again for multiple times. This is not the right approach. So when this approach is useful means when you want to create just 1 or 2 objects, this approach is useful. Technically, this is called as object literal. This is called as the object literal. That means if someone asks you to create an object, you are directly creating the object literal means write the pair of braces. Within the braces, you can write the properties. So this is technically called as object literal. Okay, this object literal is very useful to us in the situation where we want to create just 1 or 2 objects. That is fine. If I want to create just 1 or 2 objects, definitely I will follow the same approach. But when this approach is not very much useful to us, when we want to create many objects of same type, here you can see these all are of same type student. If I want to create some 100 objects here, let me take a simple maths here. Okay, so the mathematics is, if I want to create 100 objects into, if each object has 3 lines here, finally I have to write 300 lines of code. Okay, so now if the properties are increased in the object, this size will be increased. If I have taken 5 properties here, you can see 100 into 5, 500 lines of the code if we calculate only for 100 objects. And proportionally, this will be increased with respect to number of objects and the number of properties in each object. So when we want to create multiple objects of same type, then object literal is not the right choice. We need to search for some easiest approach. But this approach is very much useful when we want to create some simple objects like 1 or 2. But in many situations, it is required to create multiple objects of same type means 100 student objects, 200 employee objects, 500 product objects. These are very common use cases. How to deal with those use cases? This is not the right approach. What should we do then? At the time, we are going to use the concept called constructor function. By using constructor function, we can get rid of this problem. So the name is constructor function. We can call it as either constructor function or simply we can call it as constructor also, both are same. When the constructor function is really required means it is really required when we want to create multiple objects of same type. But when we want to create one or two objects, then you can use object literal approach only. No need to go for the constructor function. So as the developer, we are going to face with these two situations. That's why we should aware of what is object literal as well as constructor function. So once we create a constructor function, it gives the type actually. It won't give any object, but it will give you a type to you. Once you create a type, you can create many objects of same type just by writing one line of code in this way. For example, here I have created 5 persons. This is the person constructor I have taken. Once I take the constructor function, we can create any number of objects just by writing one line of code, which is very similar of creating the objects in your C++. In your C++, if you want to create an object, you will use new operator. So the same story here. So that is the use case and that is the need of learning constructor function. So now let us get rid of this problem. So now I'm going to create, now it is required to create some many objects of student type. So then I need to create student constructor. Constructor function. So all of you listen to these points carefully. The first thing is constructor function is a function basically with some speciality. Okay, because it is not a normal function, it is a constructor function. So that first we can write the function keyword as usually, no difference at all, because it is a function. And now it is a constructor function. The first difference is the name of the function should be upper camel case. Up to now we have seen lower camel case. Lower camel case means, so from second word onwards, the first character will be capital. That is lower camel case. The same notation we use it for variables, function names, for all. But when we are creating the constructor function, so the naming conventions are really very important. In upper camel case, from first word onwards, every first character is capital. So here, if you want to create the student constructor, I have to write like this, student. So here it should be S. Okay, if someone raised their hands, please remove them from the meeting immediately. Okay, so yeah, mentors. So if anyone raise their hands here, because I'm giving time to them to ask doubts after every topic. If they want to create disturbance here, remove and report them and don't allow them to join to the meeting again. Okay, so now function student I have taken. When you look at this, it is almost very same as the normal function. It is very same as normal function. But only difference as of now we observed is, for the normal functions, we can follow the lower camel case naming convention, whereas for this function, we are following the upper camel case. Upper camel case means, for example, if the class name is student details, then we can write like this. Okay, so student details we have taken here. That means S and D should be capital. For example, if it is a normal function, we write these kind of notation. This is called as lower camel case. In the lower camel case, from the second word onwards, first character will be capital. Here D is capital. But for the constructor functions, one should follow the upper camel case. So for each word, the first character should be capital. Now I want to make this as student only. Now you may ask, sir, just by changing the case, how it differentiates from the normal function? No. So this is just one of the differences. So many other differences we are going to discuss now. So now the constructor function is ready here. Once the constructor function is ready, so now what I have to do is, instead of this constructor function, we have to write object initialization logic. That is the actual difference. Generally, instead of every function, we can write business logic. If it is a function to find sum of the numbers, we can write the business logic to calculate the sum. If it is a function to check the prime number or not, we can write the business logic for that. But when you take the constructor function, the constructor functions won't contain any business logic. They contains the object initialization logic. That is the main difference between normal function and constructor function. Okay, so why object initialization logic should be inside of this constructor function means the constructor functions are used to construct objects, not to perform some business logic. If you want to perform some business logic, write a normal function and use it as many times as you can. But here we are creating the constructor function to construct objects. That's why they will contain only object initialization logic. So how can we write this object initialization logic here? So I can write the logic here later. So first I want to create object 1 or student 1. Student 1 object. So to create an object, actually, we are going to call this function by using a new operator. So generally, if you have some normal function, how can we do that? So here we can call the function in this way. This is the way to call the normal functions. But if it is a constructor function, so we have to call that function by writing new operator before that. What new operator will do is it will take this constructor and create an object with respect to the logic we have mentioned here and returns that object. So here I can write let std1 is equal to. Then std1 object is created here. If you want to create the second object, let std2 is equal to new student. If I want to create the third student, let std3 is equal to new student. See here, to create an object, we are writing just one line of code. For example, if you take the object literal, for every object, I am writing 3 lines here, at least. But if it is a complex object of some 10 properties, for every object, I need to write 10 lines of code. But here, if you want to create an object which contains 10 properties, 3 properties, 300 properties even, we can write just one line of code. Now the first object is readily available, second object is ready, third object is also ready. How we are creating objects here? So by using the new operator, call the constructor function by using new operator. What is the role of this new operator means? This new operator create an object of type student and returns that. Now std1 is the reference variable to this object. std2 is the reference variable for the second object. Similarly, std3 for the third object. Now I want to see how they look like. Let me print std1, save. You can see, so it is an empty object. Okay, student object we have created, it is an empty object. Why it is empty? Because we have not given any object initialization logic here. That's why it is an empty object. Of course, an object is created or not, that is matter here. Why? Because once object is ready, we can give properties to the object. So now we have successfully created the objects using this. Now I don't want this to be empty. I want to add the properties. How can we do that? Let me complete the business logic, hence it will be over. Now, what properties that you want to take here? So you can take them as arguments here. Name, age, city, for example. I want to take the 3 properties here, or simply let me take name and age, for example, name and city. You can take as many as you want. So for every student object, I want to give name and city. So at the time of creating the object, I should supply the values. So for the first one, Ravi is the name and city is Hyderabad. For the second object, so its name is Madhu and city is Chennai. And for the third one, name is Kiran and city is Bangalore. Okay, at the time of creating the object, we can supply the values. These are the properties. Now the Ravi, let us think about the first object. So the Ravi is taken by the name parameter. Hyderabad will be taken by the city parameter. By using them, I have to write the business logic. So I already introduced you this reference variable in previous session, which always refers to the current object. If I want to initialize the current object, I have to write this dot name is equal to name. What does it mean? This means current object. Current object means at the time of creating this first object, current object is std1. This refers to std1. When we are creating the second object, this refers to std2. When we are creating the third object, this refers to std3. So this always refers the current object. I explained that already in the previous session. This is the special reference variable which always refers to the current object. So now this dot name is equal to name. What does it mean? So on the current object, if you write some property and some value, so then it will verify the current object, does it have any properties? We know the current object is empty. When the current object is empty, then what it will do? It will create a property, it will create a key with the variable that I have given here. Here I have given the variable as name, then it will take the name as the key. Value means whatever it received as the argument. So now let me save this. You can see I have printed the student1 object. In the same way, let me print the remaining 3 objects also. std1, std2 and std3. Now you can see 3 objects are created. I have supplied the names to them. Only name I have supplied. Now each object is initialized with the name Ravi, Madhu, Kiran. Okay, so now why should we write the same here? This dot name is equal to name. Sir, here we are taking the name in 2 times. What does it mean? Remember, if I write by using this, it is referred to the property of the object. If I write that without this, that is nothing but the parameter. In the same way, now let me write this dot city is equal to city. That means here city is the property of the current object, which will get the value of this parameter. So Hyderabad is the second one. Now let me save this. Now I created the 3 objects successfully here. So each object, see the first object contains name Ravi, city Hyderabad. Take the second one, name Madhu, city Chennai. Third object, name Kiran, city Bangalore. So now if you want to create 100 objects, you need to write just 100 lines, because by writing 1 line of code, we can create an object here successfully. This is called as the constructor or constructor function, and it is called as the object initialization logic. Now, sir, I want to add more properties. Yes, you can add as many as you can. So now if you want to add one more property called age, so you can pass the value age here and take the parameter, and here you can write this dot age is equal to age. So now your doubt is, sir, why should we use the same variable name like city and city? It is slightly confusing. Why can't we take the different names? Yes, you can try. So for the name, you can take N. For the city, if we take C, then you can write here N as well as C. Hope you are clear with this now. This dot name is equal to N means this is the current reference variable, which will create the key with the name, and value is whatever received by this parameter. For first object, it is Ravi. For second object, Madhu. And for third, it is Kiran. Same thing for the city also. But generally, when we take these parameters in this way, it is like meaningless. NC is meaningless. That's why we prefer to take the names just like the properties of the object. Okay, and it is not mandatory. That is the best practice actually. Even you can take x comma y here, and you can write this dot name is equal to x, this dot city is equal to y. Still it works. But I said that variable name should be meaningful. That's why here we can take the proper thing. Still, if you are feeling confusion, you can change this to name of student, and here city of student. So here you can write the same thing, name of student and city. Hope you are came out of this confusion here. Generally, if I write this dot city is equal to city, this dot name is equal to name, generally freshers like you might confuse. So to overcome that problem, I have taken the different parameters and I have supplied. Then this is called as the business logic, hence it is completed. You can create as many objects as you can in this way. Okay, so now let us compare the previous computation with this one. Is there any change here? Previously, if I take just 3 properties, I have to write 300 lines of the code if I want to create them as object literal. If I want to create them as object literal, I have to go through 300 lines of code. But with this approach, let us see how it would be. If I want to create 100 objects here, 100 student objects, 100. So first of all, I need to write 3 lines of code or 4 lines of code here. Actually, I have taken only 2 properties. If I take age also, then it will be 3 lines of code, 3 plus not into plus 3 lines code plus for 100 objects, I need to create 100 lines is equal to total of 103. So if in the object literal approach to create the same 100 student objects as literals, we have to write 300 lines of the code, but using constructor to create the same 100 student objects, we need to write just 103. So now to understand the impact of this, let us increase. I want to create 1000 student objects and each object has some 10 properties. For example, 1000 into 10 is equal to 10,000 lines of code I have to write. And come to this part. So object has 10 properties, means I need to write 10 lines of code. And to create 1000 objects, I need to write 1000 lines only, because one line is enough to create the student. And the sum of 1010 is equal to 1010. You can compare 10,000 and 1010. So you can find the difference and the comfort in this constructor when compared with the object literals. Hope you are clear with this comparison and you already aware of when should we go for literal as well as constructor. Generally, people start comparing the things. Finally, they can decide, okay, constructor function is good, literal is not good. That is totally wrong decision. Because which is good depends upon situation. Both are good, both are useful. So the situation, what is the situation? If you want to create multiple objects of same type, then it is better to go with constructor function. If you want to have just 1 or 2 objects, then it is recommended to go with object literal, because that is simple to use. So both have their own use cases. With respect to the use cases, we can create these constructor functions. Hope you are clear with the comparison. Now I can remove the object literal from here and make the code cleaner. Okay, so this is the way to write the constructor and the way of writing this. And also you can write some functionality, also methods. For example, we have already seen objects can have methods also to run some business logic about the properties of the data. So now, for example, I want to write some method here, this dot. You can write the method name. For example, I want to write some method to give some summary. For example, I can simply write the function. Okay, and it can just return. Okay, it return the name and city, or simply okay, return. So here I can write the particular things like the values, whatever you are here. For example, name, or simply let me do one thing. This dot name plus this dot city. So if someone call this function, it can return by keeping them. Let me create some white space also in between them so that it returns. So now this method is also available. Let me save this. Now you can find each object now got the 4 properties: city, name, get summary. 3 properties. Already 2 properties are there. Now after adding this method, each object will get the method also. See here, ignore this prototype, guys. In the next 5 minutes, we are going to touch that point. Until then, you can just see the first properties except the prototype. We have name, city, get summary. Name and city are the properties. Get summary is the method. Now in each object, you can see name, city is there and get summary method is there. So each object. Okay, now you can call the method. For example, if I want to get summary of student 1, I can call the get summary here. You can see summary is Ravi from Hyderabad. Here I can write Ravi from, for example, save it. You can see Ravi from Hyderabad. Similarly, I want to get the summary of student 2. So I can write get summary here. You can see Madhu from Chennai, and here get summary, you can see, and Kiran from Bangalore. This is just a normal method I have taken just to give the summary. But just like yesterday, you have taken here to find salary by from the basic, and from the marks you calculate the aggregate, like that, whatever. And I have given assignment also to calculate the discount price of the product. and whatever the method you want, you can write it here in the same way. Then by using these methods, you can call it. This is the constructor or constructor function, and these are called as the properties, and this is the method, and the total logic is called as object initialization logic. So the constructor function can have object initialization logic inside of that, and once you create the constructor, it gives you a new type, that is student. From the type, you can create as many objects as you can by using the new operator here. Okay, by using new operator, we can create them, and finally it is completed. And now you can use these properties as well as methods also in the very normal way like this. Ask me if you have any questions about constructor function now. Now you can see I made this object as complex. Okay, so here along with primitives, I have sent non-primitives also at the time of creating objects. See here. So now this student constructor is receiving the name, city, address as well as marks. So at the time of creating object, I have supplied the name, city, these two are the strings. Third one object, address is an object. I send the third argument as an object. Fourth one is an array, so that array has received. And finally, so when we expand these objects, we can see each object contains primitives as well as non-primitives. Now each of them is a complex object here. Okay, so this is the way that we can use the constructor functions, and everything is clear now. Okay, so now here we can see a small problem. Okay, so once we identify the problem, then we can think about solution of the problem. So the problem is, when you look at each of the objects here, let me collapse them so that it will be clean to read. Each object contains how many properties here? Name, city, address, marks, get summary. 5 properties, because I have given 5 properties here. So every object will get the 5 properties. But the important thing is, for every object, name is different, city is different, address is different, marks are different. These 4 properties are different for every object, but the method contains the same business logic for every object, right? The method is not doing different things for different objects. Whatever the logic you write here, so for every object, it will perform the same logic. For example, if I have taken some calculation of the salary here, what it will do, it will take the basic from the employee or constructor and calculates the salary. If I take the product object here, if I write some method to return the discount price, it will take the MRP and returns the discount price. That means the methods are doing the same job for every object. Then the important point is, why should we have a separate method in every object, which unnecessarily increases the size of the object? Name, city, address, marks, these 4 are different for each object. That's why every object should have their own copy of name, city, address, and marks. But when we take this get summary method, that method is also existed in each object. See here, std1 has the get summary method. Similar std2, std3, all have the method. If I create 100 objects here, each object will have this method unnecessarily. Because of this, what happened? Object size will be increased unnecessarily. If it is necessary, we won't bother about the size of an object. But why we are repeatedly assigning the same, saving the same method in every object unnecessarily? That is a problem we have to focus. So let me show you a picture here for the better understanding of this. So this is the situation as of now. For example, I have created 3 objects. 3 objects contains 2 properties and 1 method like this. Now each object have a separate name, separate age, but get summary is the method which have the same business logic for every object. If I keep this get summary in every object, an additional space will be occupied by this get summary method in the object. So 3 copies of the same method unnecessarily waste the space of the memory. So how can we overcome this problem? Actually, 1 copy of this get summary method is enough. We no need to have this get summary in every object. Not only this, every method every method is not really required within every object. How can we overcome this problem? To overcome this problem, we can use a concept called prototype. So what is prototype means? Every object internally contains a property called prototype. For example, if we take this picture here, our example, here we have added some properties: name, city, address, marks, get summary. Along with this, it contains an hidden property internally, which is called as prototype. That's why every time when we expand any object, we can see the last property as the prototype. But when you look at our objects, our object need to have only address, city, get summary, marks, and name. What is this prototype? We have not mentioned anything like this dot prototype and all. But not only in this constructor, even if we take the object literal also, it has the same thing. For example, let me create the test object here. So I have taken two properties like a value 10 and b value 20, just simple object I have taken. Okay, let me print this object. So that is test object, save it. Now the test object is there. Let me expand this. A is, B is there, fine. But what is this prototype again? That means every object, when you expand, if you do not expand, you can see only the properties that you have taken inside of the object. But when you expand the object, you can see along with the properties that we have assigned, we can find a new property called prototype in this way. And the value is object with capital O. What is this? This is the topic that we are going to discuss. So from day before yesterday onwards, when we started the discussion of this object, you are observing a special property called prototype in every object, but we intentionally postponed the discussion. But today is the day, it's our day to discuss about the prototype property and its importance and all. So let's remove this function here. Okay. So what is that prototype basically means? First of all, prototype is the special property which exists inside of every object. You no need to add prototype property. If you take any object, internally it contains a special property called prototype. But what is the use? You can place the common stuff in that prototype property. Generally, the prototypes are used for inheritance. So I don't know, I'm not sure that you entered into the inheritance concept or not in your C++. One second. Prithvi, can you hear me? Prithvi, can you hear me? Okay. Can someone tell me, have you entered into the inheritance concept in your academics? Just post a message in this group, one of you. Have you entered in inheritance? Just say yes or no. No, okay, no issues. So if yeah, I got the answer actually, it's enough. Thank you for your response. No problem, guys. So very soon you're going to learn the inheritance also. What is the meaning of inheritance in reality? So the properties of your parent will be received by the child. That is called as inheritance. Okay.
Sir, sorry, sir. I was actually
no issues. I got the answer.
Sorry,
no
sir.
problem. Yeah, no issues. So inheritance means generally reusing. For example, the property of the parent. For example, if the parent has some 10 acres of land, automatically that will be given to his son or daughter, whatever it can be. That means whatever the child receiving from the parent, that is called as inheritance. That means reusability. That means the child no need to start his life with zero. So he can get everything from the parent. From there, he will start his life. It is generally happening, right? That is called as inheritance, basically. Reusability. So the concept of this prototype is required only for the reusability purpose. In the remaining situations, prototype is not required. So prototyping is really very difficult to understand, but I will try to explain you by giving real world examples. Later, you have to spend a lot of time to understand the concept of prototype, guys. So don't expect this is a simple concept which can be easy to understand just with one time of explanation. It is not really enough. You need to spend a lot of time every day until you get some clarity on this prototype. But now I will give you almost 100% knowledge about this prototype. Later, you need to read and practice until you get the proper picture about this prototype in your mind. Okay. So let's come back to our diagram here. So here, every object internally contains a special property called as the prototype. So now a special property is there called prototype. As of now, I have not taken here, it is empty. What I will do is I can just remove this get property from this object and I can paste it here. Then I can remove this get property from each of these objects. Okay, now you can see here what happened. So here now you can see that previously the get summary is the method which has 3 unnecessary copies in each object here. Whereas name and age are mandatory because these 3 objects have different names and different ages. That is absolutely fine. But get summary is the method which is not required to be part of this object. So if I move that to the prototype of these particular objects, then that prototype is accessible by each and every object here. So if you write this method for one time only, then each of the method can access that things what are existed in the prototype very easily. So now if you take this object, it have name property, age property, and from the prototype it can use get summary also. Same, it can have its name and age. From the prototype it can access get summary. So if you write one time in the prototype, that is available for all objects, so that every object can use that method unnecessarily, instead of unnecessarily having the copy of that method in each object here. Now you can see the pictorial representation of solution to the problem. Previously the same method existed as 3 copies here, but now only one definition is there which is shared by many objects. Here I have taken only 3. Even there are 300 objects, all will get this value from the special property called as prototype. But how can we do this programmatically? Diagram wise, it is very simple and the visual understanding is absolutely fine. But how can we implement this practically? Yes, to implement this practically, what I will do is outside of this particular constructor function. So I can write, so now I'm add get summary method to student prototype. So don't make it part of this constructor, add it to the student prototype. So what I will do is here I can write what is the name of the constructor here, student. Okay, it contains a property called prototype. When you type .pr, automatically you will get prototype. So constructor function dot prototype, then you can write the rest of the things, get summary, and copy and paste it here. Now you can just remove this from here. Now you can see the constructor left with only 4 properties, what are mandatory for every object. But this function get summary, now it is not existed in this object or in this constructor. It is added to the prototype of this constructor. So adding this to the prototype of the constructor means exactly the same thing has happened. It has removed from the constructor objects and it is added to the prototype. So to add to the prototype, we have to use the constructor dot prototype, because the prototype is the property existed in every constructor function. Dot, you can use the method name whatever you want, and as usually the function. Hence everything is ready. Now let me save this. You can see here, guys, let's expand this one of the objects. Now you can see this object has address, city, marks, name, but the get summary method is removed from the object. expand the second object. Here also, you can see only these 4 properties, name, city, address, marks, but get summary method has removed. And from third object also that has removed. Now, sir, if it is really removed, how can we get it? How can we find? For example, in the diagram, here I have mentioned that is not available in the object and it is moved to the prototype. Fine. But here also the same thing. Object do not have that method. It is in the prototype. Where we can find the prototype? Yes. You can expand this prototype here. You can see the get summary method. See here, the prototype is common for every object. Okay, so there is no separate prototype for every object. They will share the same prototype. Okay, so that's why here, whenever you expand the prototype property, you can see the get summary method here, here, here in every object. Now the interesting thing here is, if I call dot get summary method, so first it will search for the get summary method in the std1 object. When you look at the std1 object here, it do not contains the get summary method because this object contains address, city, marks, and name. So immediately it won't generate error. Hey, I could not find get summary method here. If it is not existed in the current object, then it will simply look at the prototype of that. If it is also not there, then it will throw the error. So now, if get summary method is not there, simply it will look into the prototype. Is it here? Yes, get summary method is existed here. Now, if I save it, you can see that method is available to this. It is working. Now, similarly, if I call this on the remaining methods also, remaining objects also, you can see still that method is available. That problem is solved. Okay, now the objects are cool and clear. No unnecessary code here. No memory wastage here. All such kind of methods are added to the prototypes. So now, sir, I want to write one more method. So the best approach is, so take the method. So student dot prototype dot, now you can write the method whatever you want here. Get y, whatever it may be, let x, y, z, anything it can be, is equal to, you can write the function here as usually. All the properties, all the methods you can add to the prototype directly instead of writing them as part of this object, hence it will work out. So that is the concept of the prototype. Prototype always contains a top level content. This can be used for reusability. So with this example, we just understand what is prototype, but reusability is not practically verified. Just we have seen the particular constructor function and also the way to resolve wastage of space, unnecessary space in each object by moving such kind of common functionality to the prototype of that one. So, but reusability we have to verify, which is actual purpose of using these prototypes, but we have not verified this property. So with this prototype property, just we overcome the problem of wasting unnecessary memory space here. So any common functionality is there added to the prototype instead of making it as the member of this constructor itself. So the prototype introduction is completed. Every object internally contains a special private property called prototype. So which contains the common functionality instead of this. Okay, so now I'm going to teach you how to reuse this reusability inheritance actually. So how can we reuse something, some existing thing by using this prototype property of this JavaScript? With this prototype concept will be completed. Okay, so you can ask me if you have any questions about this prototype. Now let us see how can we implement reusability or inheritance by using this prototypes concept. So for that purpose, we can see a concept of prototypical chain. Prototypical chain means, see guys, every object internally contains a property called prototype. So that object will get the prototype of some other object. It can also get the prototypes of some other object. Like that, everything will be in the process like this. And finally, you can check a common a top level object is there in the JavaScript whose name is object with capital O. Okay, in this prototypical chain, actually at the top level, this object with capital O has existed. Okay, now you can see two kinds of things in our programming. Object, that means, let us see here. So I can create a new file because it is enough. So I want to create a new file here. So object, this is one thing. Okay, and object, this is another thing. These two kinds of things are existed in JavaScript. If object with all lowercase letters, it is representing a data type. It is representing a data type. If object with lowercase o, that is representing a data type. But if I write an object with capital O, it is not spelling mistake or something else. Object with capital O means there is a constructor function in JavaScript with the name object. So that is the difference between these two. Object represents, that means object with small o represents a data type. Object with capital O represents the constructor function. So we created some student constructor function here. In the same way, in JavaScript, there is a predefined constructor function, which is object with capital O. And what is the benefit of this object means it contains some common functionality that is required for every object. A common functionality. That means if I create any object, that is the child of this object. So let me prove it here. So now I want to print one of the objects here. Save it. Now let me expand this object. So now you can see this is the object which contains the prototype as object with capital O. That means the std1 we have created is the child of object. std2 is the child of object. So every object we are creating is nothing but the child of object with capital O. So why they have designed in this way? In C++, in Java also, objects will follow some hierarchy. A root level object is there in every technology in object-oriented programming languages, which contains some common properties that will be inherited. So now I will prove it. Here, if I write a function called toString, I have called a function called toString here, guys. So if I write some toString function, or let me write some ABCD function, for example. All of you observe this carefully. If I run this code, what happens? So ABCD method I am calling on the std1 object. First, it will go to the student constructor and verify the method with the name ABCD. No, there is no method with ABCD. It won't throw the error. Then immediately it will search in the prototype. And in the prototype also, there is a method with name getSummary and ABCD is not there. If it is not here, it will search in its parent. Who is parent of this object here? By default, every object is the child of capital object with O. So in capital object, it will search for the ABCD method. If it is also not there, simply it will throw the error. See here, now you can see std1.abcd is not a function. Okay, fine. Now in place of ABCD, I can write a function called toString. Same story, toString method is not existed in the constructor, not existed in this particular prototype also. Now let me run this code. Now you are not getting any object, you are getting some result. It is not an error, you are getting some result here. Of course, sir, what is this meaningless result means? Just ignore this result. That means it is not throwing an error. It's not throwing an error means this method is available. So this method is returning some value. It has printed this value. And of course, I will explain you the meaning of this one later. It is not our case here. The part is the toString method is not existed in the constructor and the toString is not existed in the prototype. But why it is not throwing error? For ABCD, it has thrown the error. For the toString method, it has not thrown any error. Instead of that, it is giving some output also. Why like this? Yes, if it is not available in the constructor and the prototype, it will search in its parent. Let me expand one of the objects and you can see the object. Expand this. There you can see object prototype. Expand that object. You can see the method. See here, constructor has one property is prototype of, okay, to locale string, to string, value of. These all are the properties and methods existed in the root object, that is object with capital O. So these are some common functionalities that are required by some objects. That's why it keep all such common functionality in the root object. And that's why here, if it is not in the current object, it will search in its parent. So here the parent is object. Now, if you can see the prototype of this object, okay, so this object also has the prototype. Yeah, get set constructor expand. See, the constructor contains so many methods here. So all these kind of common methods are existed here. So that's why it has returned this value. That is the benefit. That means if parent has some common functionality, that will be automatically given to the child and the child start using it. That is the reason for the reusability. Okay, example is clear, but still it is not so exciting actually. That's why I will take a real world example for your better understanding. Let's take this example. So if you take a person means anyone, he can be an employee or student, whatever it can be. If you take the student is a person and with some special properties. Okay, employee is a person with some special properties. So some common properties of the person means he can have the name, he can have the age, he can have an address, he can have mobile number. These are the properties for every person. If you take the student, what are the special properties contained by the student along with the common properties of the person? He have some course name, because student means he's studying some class or class name or course. Those are the special properties. If you take the employee also has the same properties of person, like name, address, etc. In addition to that, he have some designation and name of the company where he's working, salary. So these are the properties. That means if I keep such kind of common properties inside of this person, so that the student is reusing these properties, whereas the employee is also reusing the properties without repeating the same properties in every constructor in this way. So now I have created the person, and person, when I create, we know that by default every object is the child of object with capital O, that is root object. Let me call it as the root object. Okay, root object's prototype is null. It do not have any other parent because it is the root object. It don't have any parent. That's why the prototype of the root object is null. Now, if you see this, student is the child of person. Person is the child of object, root object, and root object is self-existing. It has no parents at all. So this is the use case I'm going to implement now. By using this use case, you are going to understand how the reusability will be really useful to us. After listening to this example, very soon, once you enter into your C++ inheritance, definitely you can enjoy that, because you already learning now, and there you have to implement the same inheritance by using C++ syntax instead of JavaScript. Okay, so let me quickly create this example here. So for that, I've created the new file, and let me connect here 9. So the use case here I'm taking is the same use case I have taken. What is that? First, I have to create the person, and I need to use the prototype of the person as prototype of the student. So first of all, let me simply create the person constructor. So constructor function, I'm taking function person here. To make it simple, just I'm taking some common properties, simple properties, name, comma, age only, because these two are common for every person. Here I can write this dot name is equal to name, and this dot age is equal to age. Clear, the first constructor is ready. Now I want to create the student constructor. So the next one is student. So again, I can write function student. So now the student will have the name and age. That's why I can write the same thing again here, and I can write the name comma age also. In addition to that, he can have some, for example, if we take the engineering student, he can have some branch, for example. So branch is equal to, I can write branch here and I can write branch here. Okay, name dot age comma branch. Let us compare these two. As of now, there is no relation between these two. Both are independent. This is the person constructor. This is student constructor. But let us realize that student is a person. Student is a person. So if student is a person, all the properties of the person existed by the student also. The name and age, which are common properties for every human. So student is also a person, human being. He also have the same properties. But now what happened? We have taken the same properties again here. But instead of repeating the code, let us create the parent-child relationship between these two. When we create the parent-child relationship between these two, then the reusability will be existed automatically. So now what I will do is, let's remove this from here, because I want to reuse the person property. I want to make the student as the child of the particular person, because person is the parent, student is the child. If I make the student as the child, then automatically name and age also will be part of this particular student. It can reuse the properties, and in addition it can have its branch. But how can I do that? So make person as prototype of student. Now I'm going to make person as prototype of student. So what does it mean? In other terms, making student as child of person. How can we do that? It's quite simple. So student dot prototype is equal to, so here I'm going to write new person. That's it, guys. Now what happened? The student will have the prototype. Inside of the prototype, I have taken the person. So now let me create an object and I will show the difference. Now let me create an object for student. Create a student. So let std1 is equal to new student. I've created the student and I want to print the student object. So let me write std1, save it. Now you got an object here, branch undefined. Because I have not supplied the value. If I supply the value, I can get it. Branch is here. Now I want to see what is the prototype of the student. Prototype means its parent. Let me expand this. Who is prototype of the student? Person or not? Okay, now I want to see the prototype of this person, means parent of this person. Expand this. You can see, is it object or not? That means person is the child of object. That means person is reusing the properties of this object, whereas student is reusing the properties of this person. So whatever the diagram we have taken, we have implemented in the same way. I created the person. We know every object is a child of this root object automatically. That's why here, if I have taken this, so the relationship is very clearly visible here. Let me show you again. I have printed the student object. So the student object contains branch undefined. For example, let me send the branch as CSE. For example, let me save this. You can see the branch is CSE. Now I want to give the name and age also for the student. So that what should I do here? I can give the name. Okay. For example, if I have given name as Ravi, save it. Okay, name and the next one age 29. For example, I have taken these three properties. Still it is able to get this age. Let me expand here and the person, expand this. Age is undefined, name is undefined. So now what I will do is, let me create the student object first of all. I mean person object, and for that person object I can assign the values. Okay, instead of making this as the prototype, I can create an object here and let's make it like this. For example, I can supply the name as Ravi and the age as 20, for example. Okay, now you can see, guys, here branch is CSE. I want to see his name. Expand this. Now you can see the name is Ravi, age is 20, and the branch is CSC. The first object is ready. Okay, now I want to, even for example, sir, why we are taking the object with these properties? Why can't we assign them by our own? Yes, you can dynamically assign those values. You can remove it after creating the student object. Here you can write std1.name is equal to Ravi and std1.age is equal to 20. Save it. Now you can see the student object is available, branch CSC, name Ravi, age 20. But the surprising thing is the student constructor has only branch, but how it is getting the name and age here? Because the name and age are the properties of its prototype, that's why we have added them here successfully. So that whenever we expand, so here you can see the name and age. Once you expand the prototype, in the prototype they are undefined because we have not given any default values, and we supplied this easily in this way. Okay, so like that, whenever we create the constructor, okay, so the reusability can be existed. Now in std1, for example, std1 object is there. For that, I would like to call the toString function. So then what happened? It will go to the student object and search in the std1 here. So we know in the student object toString function is not here, toString method. Then it will search in its prototype. Who is prototype of the student here? Person. It will search in the person. In person also toString is not there. If it is not there, it will search in its prototype. Who is the prototype of this person? The root object. It will go and let's expand this. You can see the prototype contains a method called toString. So now when I save this, you can get the result instead of the error. That means if I take this thing here, if I search for some method here, first it will search in the current object. If it is not there, it will search in its prototype. If it is also not there, it will search in its prototype. So it will continue of searching to the upper level until it reaches to the root object. If it is not even existed in the root object, it throws the error because root object do not have any prototype. Its prototype is null. Okay, so this is called as the prototypical chain. Okay, because of this prototypical chain, the reusability can be achieved. Here we have achieved the reusability very easily. Okay, so that we have taken the person and we taken the that particular prototype of the person. That means the student have the prototype as the person, and the person has the prototype by default as the root object itself. Hence, it is completed. In this way, we can create the objects and we can set the prototypes and we can reuse existing properties. Now, if I create one more constructor here like employee, so let me write another constructor here called employee. So I can write function employee here. Okay, so what are the additional properties an employee can have? So he can have some designation. So he also have the name and age. These two are common. Okay, so here I can write this dot designation is equal to designation. Now I want to, as of now, this is an independent constructor, but I want to use the prototype of the person because employee is also a person who can have name and age. Without writing the same properties, instead of this again, simply I can write, so employee dot prototype is equal to, here I can write new person. Okay, so now what I will do is simply I can create the employee object, emp object is equal to new employee. I'm not sending any data as of now. Okay, or simply can call it as the manager. Now let me print the student object and employee object. So student object I have printed, and let me print the employee object. Save it. You can see student object, employee object both have the data. Once I expand the student objects, its prototype is person, and employee object's prototype is also person. That means these two are inheriting from this person constructor. Now, whatever the common features you placed, that will be used by this one. So age, name, these two properties are used by this one. Okay, of course, it is undefined because I have not supplied any values, because my intention is to demonstrate how the reusability can be achieved by using the concept of this prototype. Yeah, hope I have explained you with the two practical examples here about the prototype and the reusability. So ask me if you have any questions regarding this. Okay, guys, actually, my plan of the day is to discuss these remaining topics also, but I'm stopping the session with this prototypical chain. The reason is, I think you already feeling difficulty to understand these concepts. As I said, these are little bit high level concepts. So don't worry, we no need to hurry. I will teach you the remaining topics, these two topics as tomorrow's agenda. No issues, because once you understand the prototype, constructor function, prototypical chain, these three things, so the rest of the two topics are easy, but I will explain these two topics in the next session. So our next session will be on Monday, I think. So you are getting 3 days gap here. So within the 3 days, I will share you some links of this prototype and prototypal chain also website links. So along with this recording, so you can read those websites and try to practice the things. Once you are clear with these three, so actually prototype is some complex part of this entire JavaScript. Once you get rid of this, almost you can move to the interesting zones where you are not going to face these kind of issues again. But anyhow, in our programming, instead of using these prototypes of the object, in the latest versions of the JavaScript, we can use even classes also, which are similar to the C++ classes. But to understand the class concept, one should aware of the prototype and constructor function and everything. That's why I explained you these three things as of now. And the prototypical chain inheritance, that is also for the sake of interviews, that would be good. But in our real programming, real world programming, we are not going to implement inheritance in our web applications. That reusability will be in a different approach, not in this kind of prototypical chain. But the prototypical chain concept will be useful to you to crack the interviews, etc. That's why I have taken this one. But all of you be strong in the constructor function as well as prototype of an object in these two, and also take some examples of this prototypal chain. So with that knowledge, we can complete these two in the next session. In addition to these two, I can add some more topics also.